Okay, so today we're going to be doing course pack page 51, question 18. Now this question explains that 3 small children of the mass 20 kilograms, 24 kilograms, and 16 kilograms respectively hold hands, as shown, and are pulled across a smooth frozen pond by a larger boy on skates, who pulls a horizontal rope being held by the first child. The skater pulls on a rope with a force of 135 newtons. Calculate each of the following. A. The acceleration of the skater. B. The force of each pair of children that must hold hands to ensure that the chain is not broken. So as you can see, I wrote out a diagram that explains each of the masses of the children and the force being pulled. So to solve this problem, we'll first write out the givens. Mass 1, 20 kilograms of the first child. Mass 2, 24 kilograms. And mass 3, 16 kilograms. And the force applied, which is 135 newtons. Required is the acceleration. Analysis. Now, for this equation, we can derive it from Newton's second law of motion, which is, if the net acceleration force on an object is not zero, the object will accelerate in the direction of the net force. The magnitude of acceleration is directly proportional to the magnitude of the net force and inversely proportional to the object's mass. So by that, we can say that force is equal to mass times acceleration. Now all we need to do is sub in the force applied, which is 135 newtons, which is equal to all the masses, which is 20 kilograms, 24 kilograms, 16 kilograms, multiplied by the acceleration. And by that, we can divide 135 newtons by the mass to get an acceleration of 2.25 meters per second squared. And by that, therefore, the acceleration of the system is equal to 2.25 meters per second squared. Now that was question A. For question B, we can use the same givens, but the required changes. So we're going to need to know the force of the first pair, the force of the second pair. Since the force of the third pair, there is no force, since the last child is not holding on to anyone. So, by that, we can actually use the same equation, which is force equals mass times acceleration. But we're going to be subbing in, or we're going to be substituting it differently. So by that, we can say that the first force, which would be 24 kilograms plus 16 kilograms, since the mass of the holder is not accounted for, since it's only the force between the hands of the first pair and the hands of the holder, would be 2.25 multiplied by 24 plus 16, which is equal to 90 newtons, or 90.0 newtons. Now the second force would be equal to 2.25 meters per second squared multiplied by 16 kilograms, which is equal to 36.0 newtons. Therefore, the force of the first pair that must be held is 90.0 newtons, and the force of the second pair, which must be held, is 36.0 newtons. Thank you.